Okay, everybody, we are going to beat our heads in misery today. It's yet another iPhone 7 that's just boot looping. iPhone 7s love to boot loop, and they will boot loop for pretty much any reason. So we have been struggling with boot looping 7s for about 4 weeks, and I have another one, a fresh one that's come across my desk, and I want to share with you some of the things that we found out about iPhone 7s that just boot loop. One is parts. So they will boot loop if they have any kind of bad part. So we have gone out and bought a known good iPhone 7 and an iPhone 7 Plus housing just to rule that out. We've called our suppliers and said, hey, send us your front camera assemblies so that we can vet them. And some of them that are, brand new in the package, you plug them in and the thing will boot loop. They're just not good. So they really don't like replacement parts. So keeping an original housing around to help you troubleshoot these is a really good idea. This one is boot looping and it has failed to respond to my known good housing. So I've ruled out front camera and I've ruled out screen. And of course it has its own native home button. So it's time to look at the board. So at board level, what can cause iPhone 7 boot looping? We know that it can boot loop if it has a problem under audio IC. Audio IC is along that fault line where it will get these flexion-based faults. Sometimes you can't detect those in diode mode, but you can see a sponginess on some of those pads. We found boot looping ones because they've had a crack in the speaker amp up by the CPU. We found ones that had a bad speaker amp, which we found by doing diode mode under the audio IC, and found speaker amp lines were off and it ended up being speaker amp. And a lot of them are just have some kind of a problem with baseband power management or baseband CPU. So today we're going to look at baseband power management as our place to go to for this particular one, and I'll tell you why. So you're gonna have to do a bunch of diode mode readings on these to figure this stuff out. And I wanted to start off by showing you what I did today. I posted on iPad Rehab Forum. So go head over to iPad Rehab Forum where we are collecting this sort of information. This took me all day to put together. Mark did a lot of it. I finished it up today. And here at forum.mendonipadrehab.com, you can see our It Takes a Village section. So anybody can contribute to the community knowledge base, and we all have to work together on this stuff in order to be able to figure out the signature problems for the 7 and the 7 Plus, later the 8 and the 10, because these boards are going to be hard, and we need to be able to get nailed down on the signature faults so that we can get repairs done efficiently by working together before the device ages out and those difficult repairs don't make sense to do. All right, so let's see. About how long does it take to start the stream? Should be pretty soon. All right, so let's click in It Takes a Village, and I'll show you what's in there. We've got my map of audio IC diode mode measurements with my Fluke 115. And then we've got a great post from Mohammed. Mohammed is a fantastic repair guy. He's from Belgium, and he has put in there the baseband CPU diode mode measurements. And then today, this is what I did, the iPhone 7 baseband power management chip, and I made this little graphic here, which we're gonna use. And this is a heck of a lot of work. There's like 100 pads under this thing. In fact, there's 103. So 103 individual diode mode measurements painted onto this map. This information is not in ZXW yet, so we have to just do it ourselves because this is really important. So I wanted to let you guys know, head over to the forum, the iPad Rehab Forum, and if you have been struggling with something, even if you end up not fixing it, if you have learned, something on it or done a bunch of diode mode mapping, then share that so that we can all work together to figure these things out. All right, so let's get rid of that. So let's see, forum, go away. And let's look at this sort of map of the baseband power management chip. So how did this come on my radar screen? This iPhone 7 doesn't seem to have anything wrong with it. There's no water damage and there's no obvious physical damage. There's no bend in the housing. It looks like it should totally boot and have nothing wrong with it, but it's boot looping, which is the way the iPhone 7 just likes to whine and cry. All right. Thanks for this. Couple days. I write mail to you with this issue, and I'll watch this tomorrow because it's 10 o'clock at night. Those are a lot of diode mode measurements. Yes, it is. Okay. Did it throw any error in iTunes? I would assume that it would do error 4013, but I'm not going to bother to put it through that. It's not. It's, you know, they don't just heal themselves. So let's take a look at this board then. Let's take a look at the board. So we'll do microscope camera and see if anything jumps out at us. So we're going to look for cracks or sponginess or anything that seems like a bend. And we're going to look at this board. And it looks fine. I don't see anything that looks burned. Looking down here in baseband area, totally looks native. Everything looks pretty normal. I didn't take off these shields over here. I don't see any little technician damage, which can sometimes happen near the front camera flex, so that you end up getting a logic board based front camera fault. That'll make it boot loop. None of that. Looks totally legit. So where do we start? Let's just go to kind of what we know, which is the baseband PMIC. And the baseband PMIC comes in two flavors. This one, which is the larger chip, and the larger chip sits closer to this is the fault line. This is where the board is bendy along this border. So if you see the larger baseband PMIC, then that might make you want to question that. So the first thing that I did was just get out a multimeter in diode mode, and I'm just going to measure around the baseband PMIC to see if I can pick up any kind of unusual diode mode readings. So let's do that. All right, so let's do, it's almost 10, but I need to go now, so cry. All right, so let's go ahead and do some diode mode readings with red probe on ground. And we'll just pick up some of these caps around here. This one measures 0.357. And this next one in the line, I'm measuring 0 full short. All right, so those two are 0 full short. This one, 0.357. This one, 0.451. And I'm going to compare that to my known good. So this is my known good. This guy's had his PMIC off and on a few times, audio IC off and on a few times. All right, so on this cap, I'm getting 0.375. And then this one measured short. And on the good board, it's measuring 0.409. So that is a big difference. We do have a short line there on our bad board. Yep, so these two must be on the same line, 0.409, 0.375. And 0.448. All right, so that tells us that we've already found a problem on the bad board. And the problem that we found is that we have a short on whatever line these two caps here are sitting on. So let's go hunt that line down and see what we can learn about it. So let's head over to ZXW. So we'll take away the microscope and bring up ZXW. Let's get rid of that for now. All right, so let's head over to ZXW. And on ZXW, we can see, let's make that a little bit bigger. All right, let's see what line those guys are on. So these two caps are on a line called PP1V0 LDO9. And where does that line go? So this is going to be a power line for some sort of baseband function. So what's on the line? There's a big bunch of caps over here. There's the two large caps here. There is the baseband PMIC itself is on that line, and we can see that it is kind of on the fault line, right on that very edge of the baseband power management chip. And then if we look to see what does this line do, it looks like it provides power to the baseband CPU itself. So that is going to be a big problem. So now where is the actual source of the short on this line? It could be under the baseband PMIC. It could be within the baseband or under the baseband CPU or within the baseband CPU. And we see that. And if that's the case, that's going to suck. It could be any one of these caps, or it could be the baseband PMIC itself. So what do we do with that? So, you know, we really kind of can just guess. So from experience, I've seen this same short a couple of times, and I have not seen it due to the two caps that are there. So larger caps tend to act like a light bulb. A big light bulb, if you get a drop, then a big light bulb can lose its filament without actually breaking the glass, and that seems to be how these larger caps fail. With a big drop, then inside the capacitor turned into a wire, even though the cap itself doesn't look bad. We see that all the time, especially in the iPhone 6, 6S with 6S with the cap on the 5v7 image line. We see that with the backlight cap in the iPhone 6. We see it with the NAND caps in the iPhone 6 and 6 Plus. And so maybe one of these caps has become damaged due to drop damage. So that's one possibility, and we wouldn't be able to see any physical sign of that. The other possibility is that this is a short internal to the baseband power management chip. Well, the last one that I did, it was the baseband power management chip. So this time I'm just going to go ahead and go right for that rather than trying to find heat or anything like that. I'm just going to go straight to take off the baseband PMIC and see if that relieves the short. If it doesn't, then I'll go after the caps, and if it's not the caps, then it's going to be the baseband CPU itself. All right, so let's see. All right, let's see. Let's get our microscope back and see what happens if we just take off this baseband power management chip. Will our short magically go away? It could equally be under the CPU, baseband CPU, or it could equally be those caps, but they look fine. Or it could be the baseband PMIC itself. So we're going to go with that option, just really as a guess. All right, sometimes it's faster to just take a guess than it is to do a whole lot of thinking and measuring and soldering wires to inject heat. And we're just gonna see if we can get this answer quickly, because I gotta get the girls off the bus today. So let's get our hot air station turned on. Now, you do want to be careful with this. You don't want to use too much heat, because the baseband CPU is right under the baseband power management chip. So you don't want to create a short on the baseband CPU when you're trying to take this chip off. So we'll be careful, and we'll try to get in and get out. What is this nonsense on there? We're going to remember where the dot is on our chip. It's up here on the top side facing this crystal. And the iPhone 7s take a little bit more heat than other iPhone boards. All right, there is our chip off. And it looks absolutely beautiful. So we're going to clean up those pads and we'll see whether or not our short is gone. What do you think is going to happen? Oh, the iPhone 7s have been just hell to work on. It has just consumed 2 entire weeks of complete unbillable rabbit hole research repairs. It's kind of research time of year, but man, it is brutal. Alright, so we don't have anything going on with our pads. They're not bridged or anything like that. So let's clean that up and then we will go back and see whether or not our short was actually within the baseband PMIC. And it's unclear how that would happen. But the last one, that was it. So we'll see if it's turning into be a signature problem if you see that short. All right, let's see. Short will come back after power from my experience. Hope it's different on this one. The last one we did, the short did not come back, but we'll see. All right, let's get a diode mode reading now on these caps and see what the deal is. So we were wrong. We still have a short and it was not under or within the baseband power management chip because we still have a short. And let's get the actual reading on that. Let me move my multimeter so that I can see it. Yep, so it's still full short. So now we have our choices are that one of the caps is the source of the short or that the source of the short is internal to the baseband CPU itself. So let's take a look at ZXW to make sure that we all understand that. So let's go back to ZXW. And so now we've ruled out that it was on the edge of the chip itself. So we have these 2 caps or possibilities that are on the line. And if not them, we have all of these little caps that don't tend to fail. And if not that, then we have the baseband CPU, which is really opposite on the other side of the board from the baseband power management chip. Now the baseband CPU is not a chip that I can change. It's unique to the phone. So if the short is actually internal to the baseband CPU itself, then that's all you can do, and it's going to be it'll be curtains on this data recovery. So we're down to a couple of possibilities, which are that it is one of these 2 larger caps. So let's just go for those and see if we can clear the short. If it this time maybe it's actually one of the caps. So let's get microscope back and we're going to go for the caps. So the last one I did the opposite. I went for the caps first and the short was within the chip. So as always, the iPhone 7 is not really lending itself very well to signature problems where certain things tend to go bad. It tends to do whatever it wants. One of the fun ways that you can tell whether or not your short is gone is you can reflow your pads, and if your short is gone, you'll notice right away because a grounded pad is going to take a lot more heat to reflow with the mini hot tweezers than a than a pad that is on a line. So let's find out. Let's see if it's difficult to reflow these pads. This is ground, and that is not. Actually, they both seemed fairly easy to reflow. So let's see whether or not that short is still present now. Was it the middle cap? So we can find out by asking just this guy. Still short. And let's just ask whether or not this cap was a wire or not. Are you a wire? He says, no, man, it wasn't me. It wasn't me. He says he's fine. It wasn't his fault. He's been falsely accused. Now, these are large caps. And if he's fine, and I could measure his capacitance, but I'm in a bit of a hurry just to make sure that he's fine, I'd like to put him back on, because ultimately if this ends up being something that we can fix, I would like to have those caps on there. One of the ones I did, I left the cap off after solving the problem, and it still would not, it was still boot looping, and it would not pass restore. All right, let's get these quarters back on and go for the other cap and hope that we can get lucky. All right, let's see. Whenever I see a board like that, I can't thinking of what kind of hell is to root that. All right. It does kind of seem like some kind of hell. These boards are quite hellacious, I would agree with that. Those tweezers are not going to cut it for this. Move it up so you guys can see. Alright, so we got our middle cap back on, and this cap back off. Alright, let's ask him if he's a wire. Since the board is hot, it might be easier to just ask the cap if he's a wire or not. Get off. Alright, let's see if we can ask him without him flying away. He says, no, I'm not a wire either. I'm also falsely accused, and that's going to mean that our short is likely under the baseband CPU itself, which is not good news at all. Another pain in the ass unrepairable phone. Fantastic. All right, let's just make sure. Is this line still short? It sure is. Okay, let's go back to ZXW. Now we're running out of repairable options here. Let's go back. ZXW, microscope cam. Okay, we've ruled out the baseband power management chip. We've ruled out both of those caps. So what is left? We've got these sort of handful of little caps. They're pretty unlikely to fail. And then we have the baseband CPU itself. Let's look around and see if there's anything else. Are we missing anything? I don't think so. This seems like it's a pretty big major line for baseband CPU power. All right, so I'm gonna guess that it's within and therefore unrepairable the baseband CPU. But yeah, so I don't think that, I think the heat that would be required to kind of pick off all of these little caps, it would take a while, and I don't want to really subject the board to that much heat. So I'm going to flip it over, we're going to take off the shield, and we're going to at least kind of get an answer whether or not it was under the baseband CPU itself. So giant bummer. All right, RIP phone. Yep, pretty much. All right, so let's get that little cap. We'll save that just in case. Just in case we find something, if it's under the baseband CPU, that would be pretty rare. It's more likely to be internal to the baseband CPU. So that kind of stinks. All right, the symptoms of this phone are that it was boot looping in a way that it seemed to kind of have a normal boot sequence up to about 1 amp, and then it would drop, and then it would kind of hang out at the 70 milliamp, and then it would start that boot loop sequence again. All right, time to pop off this top shield and see if we can at least have the satisfaction of clearing the short, and then we'll flip that chip and see if that short was internal to the baseband CPU or not. All right. Please show the full board. No. All right. Can you please register all complaints to the iPad Rehab Complaint Department? I'll tell you what's annoying is spending an entire day diode mode mapping the baseband PMIC area, posting it publicly so that anyone can save themselves those hours and hours of work, and then having that's not good enough. Please show the whole board. Figure it out. Use your brain. If you can't figure out from looking at the board what the baseband CPU is, then you should probably not be working on the phone. That's just my opinion. All right, so I'm going to take off this shield. We're using our standard method to take off a shield. It would be really nice to know, how do these problems come to be? How does it get? What is it that happens that actually is the fault? I think if this line is actually internally shorted within the baseband CPU, that it's likely because it received an inappropriate voltage from the baseband PMIC at some point. This is taking longer than I'd like it to, so I'm going to try to figure out why. I need a little pressure. Alright, that's a whole lot of goop. I'm going to give this board a bath because that is too much thermal paste to work with, so I'm going to do that real quick. And I really wish that we had the little mini preheater. We've been using the mini preheater for jobs like this, and that has been really helpful so far. So we're going to start selling that at iPad Rehab Supply. And Mark took it home with him, as far as I can tell, unless he put it somewhere. So we just finished up course week on Friday, and then Mark went back to Jacksonville where he lives, and I think he took the preheater with him, not sure. Jessa, can we have an ohms reading to see how much of a short it is? I'm curious why the phone turns on to begin with. It doesn't turn on. It doesn't turn on. Anything works for a ship that can't be replaced. Not sure what that means. What kind of magic is that disappearing? Magic. Stream magic. All right. Let's see. The line that goes to the baseband this short, I've had that damage. Yes, I think this is going to be a line that gets damaged. In general, when you have a CPU that gets damaged, it's usually electrical damage. So CPUs are really, really prissy, and you can think of a CPU as a brain. So that's opposite to a power chip. So a power chip, think of as like big, big, thick traces, big fat wires that handle power and produce power voltages. Those things are hard to damage. The power management chips don't fail a lot. Now a CPU, think of it as a brain with little thin, ethereal, fine wire, fairy-like neurons that the whole thing is made out of. So those things run off of an unusual voltage to begin with. They run off of a very low voltage, and they have very low innate resistance to ground. So if you were to send into the CPU a voltage that is high, since it has a natural low resistance to ground, that's going to cause a huge current spike inside the CPU, which will then easily just sort of stir the soup and fritz together those ethereal, fairy-like neurons that a CPU is made out of. So it's really easy to kill a CPU with the wrong voltage. So since this is, unlikely to be, a short because of bridging of solder balls underneath there, I can't really see a mechanism for that happening as easily as I can see a mechanism for some kind of bend or flexion that somehow caused the baseband power management chip to maybe send main into the baseband CPU. Something like that would be my guess. All right, Jessa, do you see a bright future in mobile repairing line? Absolutely. I think these devices are super expensive, and I think that with the right equipment, you can change, all sorts of things on boards. I think people are wanting to keep their phones longer because I think they see less value in a new version of what they already have, and the phones are becoming really expensive. The iPhone 10 is $1,000. It's got a nice camera, but so does the iPhone 7. So it makes sense that people would choose to stay with their phone longer because there's no longer great leaps of innovation. Face ID, Face. I have Face ID. I had to go buy an iPhone 10 to do the Good Morning America teardown, and Face ID. I wear glasses, and when I'm wearing my glasses, my phone cannot recognize me. So Face ID is I would rather have the fingerprint sensor back than Face ID. Face ID is annoying. Face ID will work. It worked just now to lock and unlock my phone. Face ID. Do you know me? Yeah, so it knows me. But if I am, laying down at night in bed and I'm wearing glasses, then it doesn't know me. If I reprogram Face ID at a time where I'm wearing my glasses and then I am using the phone later, it doesn't recognize me. So it cannot differentiate Jessa's face with glasses on and without glasses on. It thinks I'm two different people. So that's, how much money are you going to pay for that? $3 maybe? I don't know. Let's grab that out of Ultrasonic. All right, let's let this dry off for a second and see what the deal is. So let's go back to ZXW, and now we're looking at that baseband CPU to see if we can at least figure out that, yes, that was the cause of our fault here. All right, so it looks like this is going to be a real bitch to get off. I would really like to have the preheater. That would make this kind of an easier job. Super densely packed in here. Yeah, and a bunch of things slid here on the backside with my removal. So I don't think we're really even going to get an answer at all. Sucks. All right, but the baseband CPU is not replaceable. In fact, I think I'm gonna do this after I have my my preheater. We ordered a bunch more of those. Unless I can see it around here. Let me look around real quick. Let's see. Mark, where did you put it? Where did you put it? All right, I have just enough time to go get the girls off of the bus. So for this one, we're going to be done. There's really not much hope for this. This is going to be certainly within the baseband CPU itself. So the line here was the PP1V0 LDO 9. And what we learned is that it was, in this case, it was not the baseband PMIC, although I've seen that same short on the baseband PMIC before. We learned that it was not the two large caps that are next to it. It's very unlikely that one of these little caps would have randomly failed because they're not really on the fault line. They're kind of internal, and small caps don't typically fail for no reason, although it's a possibility. And that really leaves the baseband CPU itself, which is not a replaceable part. The baseband CPU is unique to the device. It's very unlikely that the fault is actually under the baseband CPU. It's more likely that it's within the baseband CPU because that's how they fail. They fail from electrical damage, from some sort of an insult at the baseband PMIC, which we know gets insulted. We know those things just stop working. We know they get cold joints, and we know that they become short to ground. So if that's the case, then the baseband PMIC is going to send to the baseband CPU the wrong voltage, essentially killing it. And since this is data recovery, you need to have that baseband CPU working. Even if it was for the sake of the phone repair, we wouldn't be able to just replace the baseband CPU. So it is another sad case. Boot looping, iPhone 7, they can be due to anything. Speaker amp, audio IC, bad front camera, shorts around the front camera, technician damage, if it's got a bad home button, if it's just got a broken trace repair on the home button, all of those things cause the exact same symptoms, which is iPhone 7 boot loops. So we're gonna keep beating our heads on that. And if you have an iPhone 7 that's boot looping, you can take advantage of the iPad Rehab Forum, which now has a diode mode map. So this is what I worked on today. If you're just joining us on the iPad Rehab Forum, in the It Takes a Village community knowledge base, anybody can contribute if you're banging your head like we are on these problems, and you can post up any of your work so that we can all work together to find those signature problems. Even in this stream, a bunch of you guys have said, yep, I've had that short before. Yep, I've had that short before. Then let's talk about it. Let's collect this information here in one place under It Takes a Village community knowledge base so that we can save each other time and get to the answers of these things. If we knew, let's say we had together as a community 100 of these cases, and we knew that 95% of the 100 were due to an internal short within the baseband CPU, then it would be very quick to just get your multimeter out. You'd look to see, is that line short? Yes. And then you would know it has a 95% chance of being completely unrepairable. And that would make you work very quickly to rule out the 5% that would be repairable. And if the 5% where the short is under the baseband PMIC or one of those caps, you know, maybe even after replacing it, it still boot loops. I think that's the case of the, actually, let me look here. This one here, I think, is in that same state. Yep, PP0V9, is that it? LDO3, nope, it's a little bit of a different line. Short at the transceiver, remove transceiver, still boot loops. All right, yep, these things are proving to be really, really finicky. So please go to iPad Rehab Forum, post your experience so that we can kind of get those statistics together and just save time. There's no need to devote your life to any one repair. If it's not repairable, it's not repairable. And the faster you find that out, the better, so that you can move on to devices that are repairable. That is it for today, and it's time for me to go get the bus.